I will solve exercise 13.1, exercise 13.1, and the question numbers from question number 23 to question number 30, I guess. I will solve all these questions for you over here. The first question is, it says that there is a tangent line. One thing we should understand that if we have a curve, then any point can be located for some value of t. In this question, it has been asked that there is a t which is t naught, and that line passes through the point. Since this point becomes f of t naught, g of t naught, h of t naught, which is parallel to the vector. So when we take a derivative of position vector, then we get a velocity vector or tangent vector. The question has been asked that find from exercise 23 to 26 parametric equation for the line that is tangent to the curve. And remember that there is another line, another thing as well, that is the tangent line. So there is a V, there is a line as well. So we need to find the parametric equation of the line. We know that any function can be written as the parametric equations, and the line can also be written as the parametric equation. So here we solve question number 23, and the next questions are same, but I will solve that for you as well. I already have written those questions for you. So first of all, we differentiate. Since what we needed to find the line is to find the velocity vector v, or the derivative of r. So r can be found by differentiating position vector r, which is cos ti plus 2t plus sin tj plus etk unit vector, and the t naught is the point where we want to find the line. The next thing is we put this t naught, which is 0, this t naught 0, cos 0 is 1, plus this is 0, sin 0 is 0, 0j plus e raised to power 0, 1. So this is k. So here we get I plus k unit vector. The next thing is we need to find the location, location. So we need this location. We can find these locations by putting the value of t naught. If I put t naught is equal to some value, for example, -1, you get this point. For another t naught, we get another point, so on. So we put this t naught in the position vector as well. So our t naught becomes sin 0 is 0 plus this is 0, cos 0 is 1, so this becomes minus j. So this is minus j plus k unit vector. So we get minus j plus k unit vector, and that point becomes 0, -1, and 1. 0, -1, and 1. And the last thing that we need to understand is the parametric equation of line. So the line can be written as x is equal to x naught plus at, y is equal to y naught plus bt, z is equal to z naught plus ct. This is the parametric equation of line. This x naught, y naught is the point, that point we needed, and that point is here. And this a b c is the vector that needed for line. When you derived a line in this parametric form, you needed 2 points, p1 and p2, and you also needed one vector. That's how we are working for the line, how we work for the line. So x naught is given to us, that we found actually is 0, plus this is 0. And what is a? A is 1t. Then y naught is -1, plus b is 0t. Z is equal to z naught is 1 plus, and the ct, what is c? What? 1t. So this is the answer. T y minus 1 and z is equal to 1 plus t. So this is the parametric equation of line. Okay, 1 plus t, right. So we go to the next question now, 24. First we differentiate. The questions are the same. Then there is a point, there is a time given, or t parameter given, t naught is equal to 2. Then we find the velocity vector. Then we find the point by putting this t naught is equal to in the position vector. And this is equation of line. So we put that value over here and we get the parametric equation of line. Very simple rule. Line, sorry, curve. There is a vector and there is a line over here. Okay. 25, the same thing. First you need to find the derivative, and you also need to know the derivative, how to find the derivative of this value, this function. So I took a derivative, then we solve it, we get r at t naught is equal to 1. This t naught is equal to 1 is given. We get velocity, then p naught, it becomes origin. When we put that value over here, natural log of 1 is 0. 1 minus 1 is 0. And this is also natural log of 1. So this is 0. The point is origin, in fact. So this is parametric equation after putting these values over here, and the component of velocity vector. So 26 is also the same. I think you can just watch it, and you just need to understand the vector actually comes over here. Remember that vector come here, and the point you need to put in this parametric equation. Now 27 to 30, this is a bit technical questions, different questions. It says that if we have a curve, for example, if we have a curve and there is a line, it says that there is a line. It says that find the value of t. Before, when we put t is equal to something, we get a point. Now it says that if you have a point somewhere on the line, then you can find the point t, and you need to find the point, find the value of, we need to find the value of t. What is the value of t? So that the tangent line to the given curve contain the given point. What is the value of t? So that the given line contains the given point. The given point is this. So somewhere this point will be over here or something like that. Okay. So in this case, first we need to differentiate again. We differentiate quickly. We already did many times. 2ti 1 plus j plus 2k unit vector. This is the derivative. Now suppose that we don't know what is t. So we know that t is equal to, we don't know, but we know we can put t is equal to a. This is point of tangency. Point of tangency. This is point of tangency. If this is point of tangency, then we can put that point into the position vector to get the point a square I plus 1 plus a j plus 2a minus 3k unit vector. After putting that point, we also put this value into the uh, velocity vector or r dash a. So we get 2ai plus j plus 2k unit vector. Now, what are the parametric equation? Remember that we need to find the parametric equation. I will talk about that later on, why we needed it. So when we have the parametric equation are a square plus, then we have 2a, and remember that there was t in previous question, but t is already has been used. So we need to find another parameter, which is probably s. You can call it another name. And then we have y is equal to 1 plus a plus, then we have 1, which is 1s or s simply. And similarly, we can find the z function for the line. Z is 2a minus 3 plus this is 2 and s. Now what we can do, we can find the value for s, but first of all, this is just a point. Parametric equation gives us the point. So we put the value, the given point over here. X becomes minus 8, y becomes, for example, 2. Since this is parametric equation and parametric equation is written like this, so it generates a point. So this point, this parametric equation will be equal to minus 8. This will be equal to 2. This will be equal to minus 1. So this will be equal to minus 1. If you get the point, then it is easier. So by solving these equations, we can find the point. For example, here, which equation should I solve over here? We can find the value of s from here. 1 plus a plus s is equal to 2, and s is equal to 2 minus a minus 1. So this is 1 minus a. Then I put that value into the first equation maybe, and from that equation, a square plus 2a, and this is s is 1 minus a, and plus 8. You can solve by quadratic formula. A minus 4, a plus 2, that is equal to 0, and from here a is equal to 4 or a is equal to minus 2. So it means that t will be equal to, since t was we already put it that t was a, t will be equal to 4 or t will be equal to minus 2. These are the point of tangency, and another point lies somewhere over here or whatever that point is. Now question 28, it follows the same steps that we did in 27. First, differentiate. Since our aim is to reach at the parametric form. So this is velocity vector, put t is equal to a, then find the position vector, find the parametric form. From this parametric form, try to eliminate s from these three equations, putting given point over here, x, y, and z. After putting that, we get s is equal to minus a from here, and then put that value of s over here, and then simplifying it, a we get is 4 and t is equal to 4. 29, the same thing. Take differentiate first so that you can reach at the parametric equation. T is equal to a, velocity is given at t is equal to a, position is given at t is equal to a, and t is equal to a is over unknown point that we need to find. We have written the parametric equation, and these are equal to the point, the given point. Okay, since x, y, z is the point, x, y, z is the point, and these are written in terms of s. So we can put this equal to the point and we get the s, and from this s we have t is equal to 2 and t is equal to minus 2 after solving it simultaneously. So I hope this is the last question. The same thing, differentiate, find the velocity at t is equal to a, then position vector, parametric equation, put that parametric equation for equal to 2, since this is x, y, z, 2 minus 5 minus 3, and this is y and this is z. And finding the s from here, put that value into the second one, and here we get two values. For example, these are the values for a, and from here we can get the answer. Remember that we will choose only the positive part, since there is a natural log and natural log is not defined for t is equal to minus 5. Natural log of minus 5 will give you some unknown value, or it is not defined. So t is equal to 1 is the answer. So these are all the questions from 23 to 30. Thank you for watching.